Hello everyone. Today we're going to talk about measures of location of the data. This is also referred to as measures of relative standing. Tells you where certain values in the data lie with respect to all the other values in the data. Alright, first thing we want to talk about is percentiles. Percentiles are measures of location. Denoted P1, P2, all the way to P99, which divide a set of data into 100 groups with about, it's not going to be exact, but about 1% of the values in each group. Okay, so let's get familiar with some of this terminology. The kth percentile is in the data space. It lives with the data. Now, it might not be from the original set, but it lives with the data. It has the same units as the data. On the other hand, and this is a property of the set. Property of data set. The whole data set. The percentile of a data value is the percent of the data that is the same or less than it. So when we're talking about the percentile of a data value, we're talking about some number between 1 and 100, the data value. When we're talking about the kth percentile of a data set, we're talking about, if it's height, it's going to be like 510 is the kth percentile, or 11, 11.1 is the height of elephants here. That's the kth percentile. Okay. Formula for finding the percentile of a data value. So remember, percentile of a data value is a percent. So we're looking for this k percent. Some notation. N is going to represent the total number of values in the data set. X is going to be the number of values that are strictly less than the data value. Y is going to be the number of values that equal to the data value, which could just be 1. And K is going to be the percent that we are looking for, the percentile of the data value. What you do is you put it into this formula here. You find the proportion. So this is a proportion. The proportion of the total data that is less than or equal to the data value, the given data value. And then you multiply that proportion by 100 to get the percent. This right here just kind of rounds things out nicely. You take half as many as are equal to it. So you're sort of safely putting the data set that you're concerned with right in the middle of the data values of equal value. Okay, let's practice. Example, finding a percentile. All right, so we've got cell phone data speeds from an airport. So the airport Verizon cell phone data speeds are listed below. And they're listed below in a table of 50 values arranged in increasing order. So that's the first thing that it makes finding the number of values that are less than your data value. It makes that very much easier if you order. So you got to order the data, or sort it into the order. All right, so this is sorted. So there's 50 of these, and they're sorted. Find the percentile for the data speed of 11.8 megabits per second. So we're looking for that percent. We are given a data value, and we want to find the percentile of that value. So we need to use our formula. The formula is going to be, so K is going to equal the number less than plus half equal to all over total times 100. All right, let's plug that in. So first I have to identify 11.8. It's right there. There's only 1 equal to it, so y will equal 1. Let's count how many are before it. 10, because each one of these rows is 10, so that's, 20. So x equals 20. N equals 50. So k is going to equal 20 plus 1/2 over 50 times 100. All right, let me just go ahead and divide the 50s out. So that's going to be 20 plus 1/2 times 2, because 100 over 50 is 2. So that gives me 41. So the 41st percentile. So what that means is 40% of the data, 41% of the data is equal to or less than it. All right, and so what's the interpretation here? So notice there's a bit of a discrepancy here. This is 41, and this is 40th percentile. And the reason is because the book that I got this particular question from used a procedure different from the book that we use, and that's not altogether uncommon. The difference becomes much, much less when the amount of data is bigger. But because we only have 50 data points, it's off by a whole percentile. You will be expected to compute percentile in the way that we have shown right here, that I have shown right here, in the way that is presented in the book. So for the time being, let's just go ahead and correct this. This is the 41st percentile. Okay, a data speed of 11.8 megabits per second is in the 41st percentile. That's the interpretation here. This can be interpreted loosely as the following. A data speed of 11.8 megabits per second separates the lower 41% of data from the upper 59% of values. We have P41 equals 11.8. So we're just going to use 41. If you did it a different way, it might make it 40, only because there's so few data points. 50 is actually not a lot. All right, so we're going to modify that to 41. So P41 is this value. Okay. Now there's a formula for finding the kth percentile of a data set. So in this case, a data value is not given. Instead, we have the whole data set given. N is the total number of values in the data set. K is the percentile being used, the one that we are looking for. I is the locator that gives the position of a value from the sorted data. So remember, from above, the kth percentile is a point in the data space. I say data space to kind of differentiate it from data set. The data space is sort of like where the data lives. So if it's heights, the data space is all possible heights. The data set is the list of observations. All right. Okay, so there's a locator. So this is something that lives with the data. The kth percentile is something that lives with the data. All right. Okay. So we want 25. Oh no. What are we looking for? Oh, it's not specified yet. All right, and so here's the formula. So this is the way to find the particular point, to find the data that represents the the kth percentile. Okay, so you plug it into this formula here. Now, if the I that you get out is an integer, then just take the ith data point. If I is not an integer, then what you do is you take the integer below it and the integer above it, ith rounded down datum. Okay, so you take the ith rounded down datum and the ith rounded up datum. That's just the data, particular data point. And then you average these. You add them together. Okay, let's see what that looks like. Example, converting a percentile to a data value. Okay, so refer to the sorted data speeds. So these are the speeds that people found in the Verizon data speeds in a particular airport. Find the 80th percentile denoted by P80. Okay, so here we go. N is going to be 50 again. K is going to be 80. I is going to be not known yet. And then I think there's one more. Is there one more? Is it just those three? Yeah, it's just those three. And what we want to find is P80, that value. But first we need to find the index or the locator of that data value. All right, so we're going to put it into our formula. I equals, let's just remind ourselves what that formula is, k over 100 times n plus 1. So k is going to be 50, k is going to be 80 over 100 times n plus 1. n plus 1 is going to be, 50 plus 1. There we go. So 80 over 100 is going to be 4/5 or 0.8. And I need to multiply that by 51. So we'll go ahead and get a calculator. Um, 0.8 times 51 gives me 40.8. So that equals 40.8. Is this an integer? No. No, it's not. An integer is a counting number, 1, 2, 3, 4, 5. So it's not an integer, so what I'm going to do is I'm going to take the 40th rounded down datum and the 40th 0.8 rounded down and the 40th 0.8 rounded up. So I'm going to look at the 40th data and the 41st data. Now the 40th data is 1, 2, 3, 4. Okay, right? So this is the first. This is the, this is the 11th, 21st, 31st, 41st. So that's the 41st one is 23.1. And then this one here is the 40th. So 22.4. All right, and so what I'm going to do is I'm going to average that. So what does that mean? That means, so that this is my I. This is I rounded up. I rounded up, and this here is I rounded down. And so I has served its purpose, and now we're going to average this data. And so P80 is going to equal 22.4 plus 23.1 divided by 2. I'm going to average those things. And I get, what do I get? I get 45.5. Now if I divide that by a half, if I'm not mistaken, I'm going to get 22.75. Let me just see. 22.75. Multiply that by 2, I get 44. That one, 22.75. So that is the value. That's the 80th percentile of this data set. Now notice, it's not in the data set. No, it's not actually in the data set. But it's, anyway, but that's the percentile anyway. Now, is this rounded correctly? And the answer is yes. All of the data in this data set is rounded to the 10th place. Generally speaking, when we're doing statistics, we're going to round one more than the data. And so this is rounded to the 100th place, and that's exactly what we want. So there it is, 22.75. Now, let's look and see what the interpretation is. Oh, check. Oh, yeah, okay, let's check. Let's just check and see if 80% of the data is less than that value. So P80 equals 20.75. Let's count. So K equals what? K equals x plus 1/2 y over n times 100. Let's see if we get 80 again. So how many are less than 20.75? Well, let's see. This one is not less than 22.75, but this one is. So I'm going to count this and down. I have 40 data points here. So x is going to equal, x equals 40. Y is going to equal what? Well, y is actually going to equal 0 because none of the data points are equal to this value here. So y is going to equal 0. N is still going to equal 50. So let's go ahead and figure that out. K equals 40 plus 0 over 50 times 100. And that's going to be, if I multiply that all out, I'm going to get 80. So I recovered, I checked it. I took that data point and I said, what is the percentage of that data? What is the percentile of that data value? And the percentile of that data value is the 80th, which is what I wanted, which is what I wanted originally in that problem. Okay, cool. So the interpretation is that the value that has 80% of the data below it is 22.75. Okay, that's percentiles. Now let's talk about quartiles. Quartiles are measures of location also. Just like percentiles live in the data space, quartiles also live in the data space. So they have units. Quartiles have units equal to the data, just like percentiles. These are denoted Q1, Q2, Q3, and that's about it, really. And they divide. Sometimes you'll see Q0 and Q5. Q0 is the minimum value, and Q5 is the max. Sometimes you'll see that. It divides the data into 4 groups with about, not exactly the same, but about 25% of the values in each group. Description of the quartile. So the first quartile, Q1, is the same exact thing as P25, the 25th percentile. It separates the 25%, the bottom 25% of the sorted values from the top 75%. The second quartile is the exact same thing as P50, and it's the same as the median. That's what we call the median. So the median is P50. We know what percentiles is. P50 is the median, the middle of the data. And it separates the bottom 50% with the top 50% from the top 50%. Q3 is the same thing as P75. It separates the bottom 75% to the top 25%. Okay, now, this caution is exactly what we ran into earlier. Just as there is not a universal agreement on the procedure for finding percentiles, there certainly is not. There is not a universal agreement on a single procedure for calculating quartiles, and different technologies often yield different results. And so I want you to do it the way that I've shown you here. In the workplace, you can do it whatever way you want, but to make sure you understand this procedure, let's do it the way that I've done it. And so Excel might give you the wrong the wrong thing. So you have to know how to do it using the procedure that we have done it. Now I might just say, whatever way you please, find the percentile, and that would be fine. But it is assumed that you will use the way that I've shown you. All right, statistics defined using quartiles and percentiles. Okay, so there's a few different statistics here. These are all descriptive statistics. Interquartile range, or the IQR, that is going to be Q3 minus Q1. Whatever that value is, that is your interquartile range. Semi-interquartile range, well, that's just going to be the interquartile range divided by 2. Half of that. Mid-quartile range, the mid-quartile range is the set of values is going to be the set of values from Q1. Okay, let's see. Actually, let's see. Mid-quartile range, I don't think that's in the book. Let me see. Mid-quartile range. Oh, yeah. Okay, that's right. All right. So the mid-quartile range is similar to, well, let's not worry about that right now. We'll talk about it later as a measure of spread, as a measure of central tendency. All right, the 1050 quartile range is going to be P90, 1090 quartile range is going to be 1090 minus P90 minus P10. Okay. Okay, very good. So, the 5-number summary, you could think of this as being Q0, Q1, Q2, Q3, and Q5. Q4. Okay, for a set of data, the 5-number summary consists of these 5 values. Minimum, first quartile, second quartile, third quartile, and the maximum. And remember, that was the same as the median. Okay, so let's go ahead and find the 5-number summary for this data set. Q0, or the minimum, that's easy. That's that one right there, because the data is already ordered. Q1. All right, Q1 is going to be the 25th percentile. So that's going to be P25. And so the way I do that is I'm looking for I equals K over N times, K over 100 times N plus 1. And so in this case, that's going to be 25 over 100 times times 50 plus 1, which would be 51. And so that's going to be 0.25 times 51. Come to my calculator. 0.25 times 51 is 12.75. That is not an integer. And so what I'm going to do is I'm going to take the 12th data value plus the 13th data value. So the 12th data value is 7.7. The 13th data value is 7.9. And I'm going to average those. And I can already see that halfway between that's going to be 7.8. So we'll just take 7.8 because the average is halfway between, whatever's halfway between the values. So that means that P25, or the first quartile, is going to be 7.8. Okay, let's go ahead and find the median. That's Q2. So that's going to be the 50th quartile, percentile. So for that, we have I equals 50 over 100 plus n plus times n plus 1 times 50 plus 1. And so that's going to give me 1/2 of 50.51, which is going to be 25.5. Again, that's not an integer, so we're going to take the 25th value and the 26th value, and we're going to average those. So the 25th value is the 21st, 2nd, 3rd, 4th, 5th. Is that one? And then this right here would be the 26th. So this is, let's see, 12th, 13th, 25th, 26th. And we're going to add those together and average them. We're going to add those together divided by 2. So that's going to be 27.8. And 27.8 over 2. So that is going to give us 13.7, 14.1. And if I average those, I'm going to get 27.8 over 2, which is going to give me, let's see, 23.9. Okay, very good. So 23.9, which makes sense. It's 2 away from this one and 2 away, 0.2 away from that one, 0.2 away from the other one. So 23.9 is going to be my Q2. Now I need Q3. So that's going to be I equals, so this is going to be P75 is Q3. And so that's going to be I equals 75 over 100 times 51 times 51. And so that's going to be 0.75 times 51. And that gives us 38.25. So I'm going to take the 38th and the 39th data, and where does that land me? So this one here, let's see, this one here will be the 39th, this one here will be the 38th, and if I average those, so that's going to be 21.1, 22.2. I add those together, I get 43.3. I divide that by 2, I'm going to get 21, 21.65? 21.65. All right, and so that is Q3. And Q4 is the max, and that's 77.8. Okay, so there's my 5-number summary. All right. Well, with that in hand, let's go ahead and talk about box plots. So a box plot, also called the box and whisker diagram, is a display or a representation. Let's go with representation of a data set that consists of a line extended from the minimum of the value to the maximum value, and a box with lines drawn at the first quartile, the median, and the third quartile. All right, let's see. So the procedure for constructing a box plot. First, find the 5-number summary. The minimum is Q0, sometimes referred to as Q1, then Q2, or the median, Q3, and then the max, which is called Q4. All right. Construct a line segment extending from the minimum data value to the maximum data value, and then construct a box extending from Q1 to Q3, the median, the Q3, the third quartile. And draw a line in the box at the value of Q2, which is, as always, known as the median. That's Q2. Okay, let's take an example. So here's all the data from before. So I'm just going to use the 5-number summary from before. I'm going to draw my line. This is going to be 0.8. This is going to be 77.8. Now let's see. Let me just kind of so this here, let's just say this one here is going to be 0. Let's see, can I erase there? So that's going to be 0. And then maybe we'll have 80 right here. All right, I'm just trying to get an idea. So halfway between that's going to be about 40. Whoops. Okay, well, you know what we need to do? We need to draw a number line here. And so to do that, let's put this in red. So here's red. Okay, there's my number line. On the number line, I'm going to put 0 right here and 80 right here. Halfway between that, I'm going to go ahead and put 40. Halfway between that, those 60, 20. Okay, let's go with that. So now I'm going to put my box and whisker plot in green. So 0.8 is going to be pretty close. It's going to be right there. So there's the minimum. The maximum is going to be 77.8, which I'm going to go ahead and put right there. And so that's the maximum. I'll go ahead and write that out, 7.8. Okay, now we need to get the Q1 is what? What's Q1? Q1 was 7.8. Okay, so in red, we've got 10 about right there. So 7.8 will probably put us somewhere right there. 7.8. Okay, now what was the median? The median was 23.9. So that's just a little bit more than 23, or that's just a little bit more than 20. So I'm going to go ahead and put that right there. That's going to be 23.9. And then the other quartile, the third quartile was 77. No, okay. All right, this was a problem here. 27.8 divided by, let me just use my calculator. I don't know why I said 27.8 divided by, okay, that's 13.9. I don't know what. Oh, I put a 2 when I meant to put a 1. 13.9. Okay, not 23. 13. All right. Okay. 13.9 is what it is. So sorry about that. Just wrote the wrong thing there. I should have known that it wasn't 20. That's higher than the other quartile. Okay. Erase. Can I erase that dot? There. Okay, very good. All right, so where are we? We're at 13.9. So that'd be about, maybe about right here. So 13.9. And then the fourth quartile, where's the fourth quartile? The third quartile is going to be 21.65. So that's pretty close to 20. Put that right there. 21.65. All right, so I'm going to draw my box now. The box is going to be from the first quartile to the third quartile, and it's going to have a box in the middle, just like that. And then I'm going to draw the whiskers, and they're going to go from the minimum all the way to the maximum, right there like that. And that's my box plot. So 50% of the data is within this box, right? Because that's the middle 50%. 50% of the data is in that box. And so this gives us a very good idea of how skewed the data is. Skewed as opposed to symmetric. Alrighty. Okay, and so that is the box plot. So we sort of already, it would have been better if this slide were up there. All right. The book just goes through and does it all for us. Did we get the same quartiles? No, not exactly. Notice the slight difference in the quartiles. Is the middle quartile the same? Yes, the median was the same. Notice a slight difference in the quartiles. Very slight. Okay. All right, now I want to talk about identifying outliers. What is an outlier? An outlier is a data point that's way out there from the rest of the other data point for modified box plots. Okay, so here's what you do to find outliers. First, you find the quartiles, 1, 2, and 3. Then you find the interquartile range, which remember that's going to be Q3 minus Q1. Then what you do is you multiply the interquartile range by 1.5. In a modified box plot, a data value is an outlier if it is above the third quartile by more than 1.5 times the interquartile range. On the other hand, it's going to be an outlier also if it is below 1.4, the first quartile by an amount greater than 1.5 times the interquartile range. Okay, so to draw a modified box plot, what you do is it's a rectangular box plot just like before, except you have a modification. A special symbol, such as an asterisk or a point or a circle, is used to identify outliers as defined above. A solid horizontal line extends only as far as the minimum data value that is not an outlier and the maximum data value that is not an outlier. Okay, so let's identify the outliers from this set. Now, we already found the interquartile range. We already found Q1. Remember, Q1 is 7.8 and Q3 is 21.65. Let me just check on that. 7.8, 21.65. Great. So let's go ahead and subtract those. So IQR is going to equal Q3 minus Q1, which is going to equal 21.65 minus 7.8. So I go to my calculator, 21.65 minus 7.8 8, and I get 13.85. And that equals 13.85. Very good. Now I'm going to multiply that by 1.5. So 1.5 IQR is going to equal 1.5 times 13.85 is 20.775. Okay, great. And so now the range for an outlier is going to be Q1 minus 1.5 IQR, which equals, let's see, 7, which equals 7.8 minus that, and that gives me negative 12.975, and then also Q3 plus 1.5 IQR, and that is going to be 21.65 plus 20.775, which equals 42.425. All right, and so what we're going to do is go back to our plot above. I'm just going to go ahead and modify. No, you know what? I'm gonna copy it. That's what I'm going to do. I'm going to use my lasso here. Okay, I'm going to click. I'm going to copy. Wonderful. I'm going to come down here, and I'm going to paste. Yeah. Oh, paste image? Can I paste? That's better. You know what? Well, I don't know. I don't think we did too bad. All right, so we're right here. Okay. Let's go back to our data set and now identify which ones are outliers. There are no lower outliers because none of them are smaller than, none of them are smaller than negative 20.975. So no lower outliers. No lower outliers. Okay, but what about upper outliers? Yes, there are actually 4. There are actually 4 upper outliers because this is the outlier cutoff range here. 42.425. So there's 4 outliers at 43 at 43, 55.6, 71.3, and 77.8. Okay, so now I'm going to modify my box plot here. In the modified one, I guess I'll go ahead and put in this purple or violet or whatever. So there's no other outliers, so I'm just going to go ahead and put that there. And this is all the same, right? Everything else is the same. The only thing that changes is where the end goes. So 38.5 was the last non-outlier. So that will be something like, I don't know, right here. 38.5. So that's going to be right there. 38.5. And then we have some outliers, one at 43. So I'm going to put an X at the outlier. So there's one at 43.0. And then there's one at 55.6. Then there's another one at 73.3. 71.3. Cross that out. And then there's of course the maximum there, which is an outlier. So that is my box and whiskers. That's my modified box plot with the outliers. So it tells me that the great majority of my data is really just in between 0.8 and 38.5. And then the rest are some sort of outrageous values there. Okay, that's it. All right, everybody. I apologize for some of those mistakes earlier. I hope I cleared up all of them. Let me know if there's something I didn't clear up so I can let people know. Okay, everybody, have a great day. Good luck on your quiz and good luck on your homework. All right.